In mathematics, linearization refers to finding the linear approximation to a function at a given point. In the study of dynamical systems, linearization is a method for assessing the local stability of an equilibrium point of a system of nonlinear differential equations or discrete dynamical systems. This method is used in fields such as engineering, physics, economics, and ecology. Linearization of a function. Linearizations of a function are lines ones that are usually used for purposes of calculation. Linearization is an effective method for approximating the output of a function at any based on the value and slope of the function at, given that is differentiable on and that is close to. In short, linearization approximates the output of a function near. For example. However, what would be a good approximation of for any given function, can be approximated if it is near a known differentiable point. The most basic requisite is that, where is the linearization of at? The point-slope form of an equation forms an equation of a line, given a point and slope. The general form of this equation is using the point, becomes. Because differentiable functions are locally linear, the best slope to substitute in would be the slope of the line tangent to at. While the concept of local linearity applies the most to points arbitrarily close to, those relatively close work relatively well for linear approximations. The slope should be, most accurately, the slope of the tangent line at. Visually, the accompanying diagram shows the tangent line of at. At, whereas any small positive or negative value, is very nearly the value of the tangent line at the point. The final equation for the linearization of a function at is 4. The derivative of is, and the slope of it is. Example, to find, we can use the fact that the linearization of it is, because the function defines the slope of the function at. Substituting in, the linearization at 4 is. In this case, so is approximately. The true value is close to 2.000249998, so the linearization approximation has a relative error of less than 1/1,000,000%. Linearization of a multivariable function. The equation for the linearization of a function at a point is. The general equation for the linearization of a multivariable function at a point is. Where is the vector of variables, and is the linearization point of interest? Uses of linearization. Linearization makes it possible to use tools for studying nonlinear systems to analyze the behavior of a nonlinear function near a given point. The linearization of a function is the first-order term of its Taylor expansion around the point of interest. For a system defined by the equation, the linearized system can be written as where is the point of interest and is the Jacobian of evaluated at. Stability analysis. In stability analysis of autonomous systems, one can use the eigenvalues of the Jacobian matrix evaluated at a hyperbolic equilibrium point to determine the nature of that equilibrium. This is the content of linearization theorem. For time-varying systems, the linearization requires additional justification. Microeconomics. In microeconomics, decision rules may be approximated under the state space approach to linearization. Under this approach, the Euler equations of the utility maximization problem are linearized around the stationary steady state. A unique solution to the resulting system of dynamic equations then is found. See also, linear stability, tangent stiffness matrix, stability derivatives, linearization theorem, Taylor approximation, functional equation, references. External links, linearization tutorials, linearization for model analysis and control design.